What if the next giant leap in technology wasn't some rare, exotic metal, mined from just a few corners of the globe? What if instead it came from the most common, most abundant thing you can possibly imagine? Something you literally have in your kitchen right now. Yep, we're talking about salt. And it is right at the heart of a tech revolution that is about to completely change everything you think you know about electric cars.
CATL, obviously the world's largest battery manufacturer, if you didn't know, has already confirmed that its sodium-ion cells are entering mass production. Energy density has risen to 175 watt-hours per kilogram at the cell level, and it's lower than the very latest LFP chemistry, but a little bit more than what we've been used to for the last few years, so definitely something we're all interested in now.
But to really get why this is all happening now, we've got to start with a really specific, and let's be honest, a super frustrating problem. If you've ever driven an electric car in a cold climate, you know exactly what I'm talking about. The temperature plummets, and suddenly your car's range it vanishes into thin air. And nope, it's not just in your head. The hard truth is that conventional lithium-ion batteries, the tech that powers pretty much every EV on the road today, can lose up to half of their range in freezing weather. That's a huge performance failure, and it's been a massive roadblock for millions of people thinking about switching to an EV. Alright, so let's get into it. To really appreciate the solution, we first have to wrap our heads around the science behind this massive flaw. I mean, why are our most advanced, high-tech batteries so incredibly vulnerable to just a little bit of cold? Well, it really all boils down to some pretty basic chemistry. See, inside a lithium-ion battery, these tiny charged particles, the lithium ions, they have to swim through this liquid called an electrolyte. But when it gets cold, that electrolyte thickens up. Think of it like honey you put in the fridge. The ions just can't move freely anymore, and that just cripples the battery's performance. The result? That insane 30 to 50% drop in range. And what's even worse, the car then has to waste its own precious battery power just to heat itself up enough to work, which creates this awful, vicious cycle. For people in places like Scandinavia or northern Canada, this isn't some minor inconvenience, it's a total deal breaker. But here's the thing. The problem with lithium goes way, way beyond just a chilly winter day. The entire system is built on a foundation that's turning out to be incredibly fragile, wildly expensive, and just super complicated. The cold weather issue, that's really just a symptom of a much, much bigger problem. And this right here, this is the core of the economic problem. The raw material for a sodium-ion battery, we're talking sodium carbonate, costs about $100 a ton. Meanwhile, battery-grade lithium carbonate has been hovering around $18,000 a ton. I mean, that is just a staggering, mind-blowing difference, and that cost trickles down into the price of every single EV. This crazy cost is just one piece of what the industry calls the lithium bottleneck. The world's lithium supply, it's all concentrated in just a handful of countries, which basically makes the entire auto industry a hostage to geopolitical games. Its price swings are so wild, it makes long-term planning a total nightmare for car makers. And on top of all that, a lot of these batteries also depend on other materials with really fragile supply chains, like cobalt and nickel, which just concentrates the risk even more. The whole system is basically screaming for an alternative. So okay, if lithium is the fragile, expensive king, who's the challenger? Well, it's a technology that was actually looked at decades ago, but then kind of got pushed to the side. Now it's back, and it's back with a vengeance. So let's meet the hero of our story, sodium. This number says it all. Sodium is 1,400 times more abundant in the Earth's crust than lithium. It's not locked away in a few special mines. It's in our oceans, it's in salt flats, it's quite literally everywhere. The supply is basically limitless, and it's spread out all across the globe for everyone. And the perks go way beyond just being everywhere. They go right down to the nitty-gritty of engineering. So in a battery, you need these thin metal foils to collect the current. For lithium-ion, the anode part needs expensive copper foil. But sodium, because of its chemistry, it doesn't have that problem. It can use cheap, lightweight aluminum foil for both the anode and the cathode. Now that might sound like a tiny detail, but trust me, when you're making millions of batteries, it adds up to massive cost savings and a much lighter battery pack. So having abundant cheap materials is a fantastic start, but it doesn't mean a thing if the performance isn't there. For years, sodium batteries just couldn't compete on energy density. That was the big puzzle that the world's largest battery maker, CATL, decided to solve, and their solution is a technology they've branded Naxtra. This was the first number that made the entire industry stop and pay attention. Naxtra hit an energy density of 175 watt-hours per kilogram. All of a sudden, this wasn't just some battery for, stationary storage. No, this was a number that was directly on par with the mainstream LFP lithium-ion batteries that are powering millions of affordable EVs today. Just like that, the density gap was closed. But this is the metric that changes the entire game. Remember that winter problem we started with? At a bone-chilling minus 40 degrees Celsius, a temperature where most lithium batteries are basically paperweights, the Naxtra battery keeps over 90% of its capacity. It doesn't just work in the cold, it absolutely thrives in it. And what about how long it lasts, longevity? The Naxtra battery is rated for over 10,000 charge cycles. Just for some context, a lot of really excellent LFP lithium batteries top out around 3,000, maybe 5,000 cycles. So this isn't just a battery, it's a long-term asset. It's designed to last for well over 1,000,000 miles of driving. Okay, so let's put them side by side, head to head. Energy density? Yeah, they're in the same ballpark, totally competitive. But then the advantages for sodium just start piling up. Capacity in extreme cold, it's not even a contest. Cycle life, we're talking a 2-to-1 advantage, easy. Even the anode materials are smarter. Naxtra uses a self-forming anode, so it doesn't need expensive graphite and it uses cheaper aluminum instead of copper. And finally, safety. Sodium-ion chemistry is just naturally more stable, meaning it doesn't have the same fire risk if it gets punctured. It is a decisive win on almost every single front, except for the absolute peak of energy density. Alright, so the tech is seriously impressive, but you might be sitting there thinking, okay, this all sounds great, but it's probably years away. It's not. This isn't some science experiment in a lab. This is happening right now, and 2026, that's the year it goes completely mainstream. I mean, the speed here has been absolutely incredible. CATL showed off its first generation back in 2021. By April 2025, Naxtra was launched as a real commercial brand. Just a few months after that, they confirmed plans for a massive rollout. And now, in 2026, mass production for cars and trucks is officially kicking off. The tipping point isn't coming, it's here. And this isn't just talk, not just some press release. We're talking about real vehicles hitting the actual road. Changan Automobile is launching the Nevo A06, the world's very first mass-produced passenger car running on a sodium-ion battery. GAC Aeon is putting them into its battery swap stations, which is a perfect use case. And it's already happening in the commercial world, with light trucks and vans using this tech to conquer those tough, cold-weather delivery routes. This is a rollout on multiple fronts that's going to touch pretty much every part of the electric world. But this is where the story takes a really fascinating turn. CATL's vision isn't for sodium to just come in and replace lithium in some kind of winner-take-all fight. Nope. The future they see is way more intelligent, way more collaborative. They call it a dual-star future. And the heart of this whole vision is a concept called AB battery architecture. So instead of picking one chemistry over the other, they're actually combining them. Just imagine a single battery pack that has both sodium-ion cells and lithium-ion cells, all working together like a team, with a smart battery management system, the BMS, acting as the coach. So here's how this brilliant tag team approach actually works. When it's freezing cold, the tough-as-nails sodium cells wake the system up, giving you instant power without any hesitation. They also act as this super stable benchmark, which helps the system get a way more accurate read on the lithium cell's state of charge, something that's notoriously tricky in the cold. Then, once everything's up and running smoothly, the high-density lithium cells take over for that long-range cruising. The whole time, the BMS is constantly blending and switching between the two, giving you the absolute best of both worlds. You get lithium's range, and you get sodium's resilience. This whole philosophy was captured just perfectly by CATL's chairman, Zhang Yukun. He said, "The future of energy is not about one-size-fits-all solutions. It's about letting different chemistries collaborate to serve people, not just specs." And that right there is a fundamental shift. It's moving away from just chasing the highest number on a spreadsheet to actually solving real-world problems for real drivers. And that leaves us with a pretty provocative final thought. For years, we've all been looking for that one single perfect battery chemistry that would rule them all. But maybe that was the wrong question all along. What if the real breakthrough isn't finding a single winner, but creating a powerful alliance? Our mission here is always to decode the complex technologies that are shaping our future, and what we've seen today is nothing short of a fundamental shift in how we think about storing energy. The takeaway is crystal clear. The era of relying on a single flawed battery chemistry is coming to an end. The next step is for all of us to watch as this dual-star approach spreads from passenger cars to grid storage and way beyond. Because the sodium-ion revolution, powered by the most common salt on Earth, isn't on the horizon, it's already here. Thanks for tuning in.